Hey everyone, welcome back. So today's explainer is diving into something that's honestly one of the most fascinating and frankly urgent challenges every single developer is facing right now in 2026. We are looking at the ultimate dual mandate, building incredibly smart AI agents while simultaneously locking down the fundamental security of our underlying systems.
I want you to think about this for a second. What do bleeding-edge autonomous AI agents have in common with, well, legacy, decades-old web security vulnerabilities? The answer: they are both sitting right there in your production environment. You can build the most advanced reasoning engine in the world, but if your basic file system isn't secure, all that brilliance is just a massive liability. Today, we're bridging that gap.
All right, let's get right into it. We're going to break this down into a few key areas today, starting with the modern developer's mandate. Then we'll look at choosing an AI framework, uncover the real secret behind context and tracing, and finally, we'll pivot hard into infrastructure, specifically the directory traversal threat and how to actually secure your file access.
So, part one, the modern developer's mandate. It's all about this intense balancing act between rapid innovation and hardcore security.
Listen, if you're an engineer today, you're basically fighting a war on two fronts, right? On one hand, everyone expects you to push the envelope. You're out there building these autonomous AI agents that can actually reason, plan, and execute tasks dynamically. But literally on that exact same day, you're also expected to defend against foundational 20-year-old web vulnerabilities. To achieve true production readiness today, you can't just be the AI person or the security person. You've got to master both. It's the whole shebang.
And if you're sitting there thinking, I've got time to figure this out later, well, check out this number. According to McKinsey's State of AI, 23% of organizations are already scaling agentic systems in at least one function, nearly a quarter. This isn't just some fun sandbox experiment anymore. It's a right-now, real-world production reality. Your competitors are deploying these systems, which means the race to build them securely is officially on.
Moving right along to our second area, choosing an AI framework. Let's talk about navigating this incredibly crowded ecosystem. Here's the truth. There is no single best framework out there. It 100% depends on what you're actually building. For instance, if you're tackling really complex, stateful, multi-step reasoning workflows in Python, LangGraph is absolutely your go-to for that explicit control. But maybe you love Python but really just want deep type safety and validation without all that heavy orchestration, then Pydantic AI is a brilliant choice. Now, what if your whole team lives and breathes TypeScript? Well, Mastra has emerged as a top-tier option for that stack. And then if you're building an app that needs role-based multi-agent collaboration, like a researcher agent handing off notes to a writer agent, Crew AI is literally purpose-built for that. You've got to match your team's primary language and your workflow's complexity to the right tool.
But, okay, here's the massive narrative twist. The framework you choose, it actually matters way less than what sits underneath it. Let's get into the context and tracing secret, which is the real key to scaling in production.
Just consider this metric from a recent LangChain survey of over 1,300 practitioners. 32% of teams say that unreliable performance is their #1 blocker to scaling AI agents. And guess what wasn't in the top 4 blockers? Framework selection. Yeah, the framework isn't what makes your AI hallucinate or fail. It's the lack of reliable context.
Which brings us to this absolutely foundational concept, context architecture. Look, none of those frameworks we just talked about have any idea what your internal business acronyms mean out of the box, right? They don't magically know where your canonical revenue figures live. So context architecture is this framework-agnostic layer that holds all your business meaning, your source of truth, and your governance rules entirely externally. You connect to it using standardized interfaces like MCP, the Model Context Protocol. Think about it. If you embed all that core knowledge directly into a specific agent's memory, you're going to have to rebuild it from scratch the second you decide to change frameworks.
To make this super concrete, let's look at what Joe Dos Santos over at Workday had to say. They realized their AI couldn't even answer basic questions until they built a translation layer. He noted that all the work they did to establish a shared language among actual people at Workday can now be leveraged by AI via Atlan to MCP server. By decoupling that shared business language and serving it up via MCP, literally any AI agent they build, no matter the framework, can tap into that exact same governed truth. That is how massive enterprises are actually scaling accuracy.
So the big takeaway here is absolutely crucial. You have to separate your context from your orchestration. Do not embed your core business logic inside a framework's memory.
Instead, hook it up via standardized interfaces like MCP. And on top of that, you absolutely must trace every single step your agent takes using open telemetry tools, things like LangFuse. When an agent inevitably fails in production, you need to see exactly which prompt, which tool, or which context retrieval went off the rails, all in a structured timeline. Doing this ensures your framework choice remains just that, a reversible engineering choice, not a permanent and escapable lock-in.
All right, now let's pivot to the infrastructure side, the directory traversal threat. Because let's be honest, a brilliantly smart, context-aware AI agent is completely useless if it's running on a compromised server. Directory traversal, also known as path traversal, is one of the oldest yet still most devastating web vulnerabilities out there. It happens when an attacker manipulates file paths using those classic .. sequences to basically break out of the intended directory. This lets them read arbitrary files right off your server. We're talking configuration files, source code, or even highly sensitive operating system passwords. Let's break down the actual mechanics of how this works. In a normal, safe request, a user might ask for report.pdf, and the server safely appends that to the uploads folder. Everything works perfectly. But in a malicious request, the attacker inputs a string of .. slashes, followed by etc and password. The server blindly concatenates this, effectively backing all the way out of that safe uploads folder, traversing right to the root directory, and just handing over the password file. It's elegantly simple, and it's incredibly dangerous.
So, how on earth do we stop this from happening? Especially when our AI agents are dynamically requesting files all the time. That brings us to our final section, securing file access and locking down the system.
Defeating this attack requires a really strict logical flow in your code. First, you receive the input file name. Second, you sanitize that input to strip out obvious malicious characters. But, and this is key, you don't stop there. Third, you resolve that user input to an absolute definitive path on your server. Fourth, you validate that this newly resolved absolute path actually starts with your intended safe base directory. If it doesn't, boom, you reject it immediately. Only after it passes that strict absolute path validation do you finally proceed to step 5 and actually serve the file.
To sum up this defense-in-depth strategy, literally never trust user input. Always validate against resolved absolute paths. Whenever you can, use allow lists, meaning explicitly stating exactly what is allowed instead of trying to play whack-a-mole by blocklisting every possible variation of a .. attack. And you should definitely go a step further with infrastructure isolation. Use containers or root jails to create isolated environments, so even if an attacker manages to break out of a folder, they're still completely trapped. But honestly, the absolute best defense is to avoid user-provided file names entirely. Just use secure database IDs to reference your files instead.
Which brings us to our final thought for today's explainer. We spend so much time and energy obsessing over which AI framework to use, how to build out these complex context layers, and how to trace our agent's reasoning. But I want you to look at your architecture today and ask yourself one question. Your AI agents might be incredibly smart, but is your underlying file system secure enough to handle them? Something to really think about. Thanks so much for joining me today. Keep learning, keep building securely, and I'll catch you in the next one.